In this video, we're going to be talking about activities. Specifically, we're going to be talking about the life cycle because it's very, very, very important that people understand how activities are loaded and unloaded because there's so many concerns about things such as usability as well as performance and resource usage. So, I think it's incredibly important that people understand how the activities interact with each other, how they get loaded and unloaded. Also, I do want to talk about how activities can launch other activities and return results, and we'll see how we can deal with that. So yeah, it should be a pretty straightforward video. And because as important as this stuff is, it's not that scary. There's just a few rules that people have to be aware of when working with Android activities. If you follow those rules, things will work out just fine. But you have to be aware of the fact that there are a lot of different scenarios in which different code paths might be executed. So yeah, let's go ahead and get started. I'll create a new Android project, and I'll just call this Project Activities. Very uninspired name, but that's pretty much true of any name that I come up with. And right here, we're going to select a blank activity, and we're going to leave it as main activity. So let's go ahead and give it a sec to build. Maybe more than a sec to build. I mean, it's Java. I mean, yeah, I pointed out that last video, but really, what else am I going to say at this particular moment? Because I can't do anything. And Gradle is still gradling. And the render is still rendering. And now it's rendered, and now it's indexed, and now it's gradled. So, let's go ahead and get started. What I'm going to do is I'm going to put together a simple example. The most trivial sort of activity changing event is something we saw in the last video with screen rotation. I'm going to show you guys how we can handle screen rotation in a very elegant way without resorting to a hack, which I'll show you the hacky way in after I show you the correct way of doing it. So let's go hop over into our text panel over here so we can write our XML for our layout. And I'm going to put together just a basic example similar to what we had before. So I'm going to put in a text view. It's going to have a width of match parent, wrap content. Let's give it a padding of 16 dp and a background of light gray. I don't know. Maybe darker gray. Sure, why not? And then we're going to give it an ID of, let's do activity main text, and let's give it a text of not yet set. And that'll make more sense soon. Next up, I'm going to create a button with the width of match parent, height of wrap content. Let's do align parent bottom true. Let's give it a text of a button. Let's give it an ID of ID activity main button. Okay, so we have a text view and a button, pretty much the exact same thing that we had in the last video, and they're going to do the same thing, effectively. So let's hop back over to mainActivity.java. What we're going to be doing here is we're going to be nuking our onCreateOptions menu and our onOptions item selected. Nuke both of those, and now we're left with just our onCreate method. So I'm going to go ahead and create a field called privateIntCounter, and this will contain a number. That's why it's called a counter, for how many times we press the button. Then I'm going to say final text view equals cast to text view, find view by ID arda. Yes, I'm aware of tools that make this faster, but it's also important to, I don't want to clog all this up with third-party tools. There are tools that you can use. I think it's called, what is it called? Butter knife? Yeah, I'm pretty sure that's what it's called. And it makes it so you don't have to write this find view by ID all the time over and over and over again. But anyway, let's go ahead and do view button equals find view by ID. Our ID activity main button. And then we'll say button set on click listener, new on click listener. And then we'll say counter plus plus text view dot set text integer toString counter. All right, not that exciting. So let's go ahead and hit launch. And my getting motion is already running, so the launch dialog should appear with that device. Once Gradle decides to... There we go. Okay. So we have not yet set, and then we can click the button and we see 1, 2, 3, 4, 5, 6, 7, blah, blah, blah. Now, what happens when we rotate? This is where things get interesting. Notice how we are now blank, where it now says not yet set. So what happened? Well, in the last video, I'd explained that the Android operating system completely destroyed this activity, destroyed everything in this activity, and then recreated it. So I can prove that to you guys by coming up here and doing some logging. So quick aside, this is how you do logging with Android. A common convention and a very easy way to go about doing logging is creating a private final string tag at the top of your class. So I'm going to say private final string tag, and I'm going to name it, or string is capitalized, of course, because we're in Java. We're not writing in C#. Tag, and then we're going to say main activity. What is tag? Tag is just going to be the prefix that we have on all of the log messages. This is not required, but it's a convention. It's a convention or let's do private final static tag. And the convention is to create a tag field at the top of your class with the name of your class in it, so that we don't have to repeat that every single log message that we write. And you'll see that in a second. Also, for you C# people out there, static final is equivalent to string. To my knowledge, there is... Oh yeah, const is a reserved word in Java but isn't used. So static final will give you the equivalent behavior as if you were to have made it const. Okay, so to prove to you guys that onCreate is getting called again, I'm going to log out a message. How do I log? I'm going to say, well, log. Log dot. And if we do log dot, we'll get an autocomplete window of a bunch of stuff. We have D for debug messages. If you're familiar with any logging framework, you'll understand the different severities, everything from info to debug to warning to error to fatal. So that's what these represent. Notice how each one of these methods takes in a tag, which is the prefix, which we're going to pass our tag constant into, and it also takes in the message itself. We can throw in a throwable. What is a throwable? A throwable is an exception. All exceptions inherit from throwable. Anyway, so we have D for debug, E for error, I for info, V for verbose, W for warning, and WTF for, fatal. More or less like this should never happen sort of thing, which sometimes we do. And it's funny, WTF in the Android log thing stands for what a terrible failure. I think that's kind of cute. Anyway, so we have our different methods. So let's go ahead and do something. Let's do an info. So on my info, I'm going to pass in my tag. Then I'm going to pass in onCreate. Let's put in some dashes so we can actually see it in the log message. So let's go ahead and hit run. And wait. So, there we go. There's our onCreate message. Now let's rotate the device. I rotated the device on my end. Now we have another onCreate method, or a message. Let's rotate it again, and we have another onCreate. So we see that it's being created every single time. So the question is how do we save our instant state? Might it have something to do with the parameter name saved instant state? It does, but I don't want to get quite there just yet, because there's actually quite a few other things that we have to be aware of, quite a few other methods and callbacks we have to be aware of when dealing with activity life cycles. What I'm going to do, because we're going to be creating multiple activities in this lesson, in this video, I want to create a base activity class that main activity will inherit from that will automatically log every single life cycle event. So I want to show you all the life cycle events, all the ones that we need to care about anyway, and when they occur, during the creation and recreation of our activities. So underneath our Java folder, I'm going to open up the com.buzz activities package, and I'm going to right-click, select new Java class, and I'm going to name this, how about base activity? That's a good name for a base activity. Hit OK. Remove this ridiculous comment. And let's go ahead and make sure that base activity extends our action bar activity. Not action bar activity. And then I'm also going to make it abstract, so just to be very, very clear that this is a base activity and it's not to be instantiated. So what is the base activity here going to do? Well, all it's going to do is it's going to print out log messages for things like when certain lifecycle events happen. Now, what I'm going to do here, however, I am going to go ahead and I'm going to say private string tag, or let's just do tag. Now, the reason I'm doing private string tag is I want it to be mutable. You'll see why in a second. Let's do our onCreate method first. I'm going to say public void onCreate bundle saved instance state, and then super onCreate saved instance state. Then what I'm going to do is I'm going to say tag equals get class, not get class loader, dot get name. So why am I doing this? Well, this base activity is going to be doing a bunch of log messages. We're going to have multiple activities that inherit from this base activity. I want the tag of what it's going to be logging out to be the actual concrete class that inherited this base activity. Meaning we're going to use some super, super fancy reflection to get the name of the class that we're working with after it's been inherited. So, for example, main activity will inherit base activity. GetClass.getName, when ran against main activity, will return main activity. It won't return base activity. This way we'll be able to distinguish between the different lifecycle events in our different activities. Then after we do that, just for good measure, I'm going to go ahead and log E. I'm going to log an error because I want to be able to be able to see better in the log messages where our custom log messages appear. So I'm going to say log E tag, and then I'm going to say -- on create. So then I'm going to, before I do the other lifecycle methods, I'm going to come back up into main activity. And instead of extending action bar activity, I'm going to extend base activity. And, okay, so when I said public void onCreate here, what I meant was protected void onCreate. Now, the interesting thing about Java inheritance is you can inherit a method with a different accessibility than the inherited method, as long as the new accessibility is more accessible than the previous accessibility. And I'm just wondering how many more times I can say accessibility in that sentence. Basically, what that means is technically onCreate is a protected void method. It's a protected method, but I can override it with a public method. But since I now made in the chain of inheritance, I now made onCreate a public method. Now I can't inherit it as a protected method. I have to inherit or override it as a public method. However, I do believe in keeping things as protected as possible, so it was my mistake there that I made that public. I should have left it protected. By leaving this protected, the protected state of the method is well protected, and we're able to override it protectedly in this class. If that was a bunch of gibberish, just change that from public to protected and you'll be okay. Anyway, now that we're inheriting from base activity, or extending in Java speak, I guess, let's go ahead and, I already removed that log. So let's go ahead and test this first. Make sure we got everything set up correctly. And as you see right there, com.buzz.activities main activity onCreate. So you see the tag is the full class name. I suppose we could also, instead of saying tag equals get class get name, we could just say get simple name. And as you'll see with this, it will not include the package. So now we're running and we see just main activity onCreate. And that's exactly what we want. And we spent a whole lot of time talking about log tags. So, now that main activity is inheriting or extending from base activity, and base activity is logging properly, let's go ahead and introduce the other lifecycle events so that we can watch this happen in the log and understand when these callbacks need to be executed. So let's go ahead and do some stuff. So after we do the onCreate, there's another callback, and it's going to be protected. It's going to be onStart. So now, remember, always call through to the base class. You'll get an error otherwise. So I'm going to say log.e tag onStart. So onStart gets invoked after onCreate in all circumstances. Next up, we have onResume. Now, onResume is interesting because this method is going to be invoked. This method is going to be invoked both on the first startup as well as if our activity ever becomes paused and then needs to restart. Speaking of pausing, we also have onPause. OnPause happens in the special case which our activity becomes paused, which we'll talk about why an activity might become paused when we get to the actual diagram. So then, after that, we're going to have a onStop. OnStop is all about the activity being stopped for all intents and purposes, but not necessarily destroyed yet. So that's when that method gets invoked. We also have this onRestart method, which only happens, onRestart, which only happens when an activity is stopped and then restarted. Finally, well, almost last, we have onDestroy, which happens when this is the destructor. For all intents and purposes, onDestroy is the destructor of the activity. You can think of it as the onDispose of the activity. Now there's one more lifecycle event that we can implement, and that I want to just throw in there just to show you guys. And that is the onSave instance state and the onRestore instance state. So we have this protected void onSave instance state, which takes in one of these mysterious bundles. This was more typing than I was intending it to be, but that's okay. And then we also have a protected void onRestore instance state bundle saved instance state. I should probably go ahead and add my log messages here. So tag onSave instance state. Oh, did I misspell that? What's it complaining about? Whatever, I don't care. And then we'll go ahead in here, and we'll say log e tag on restore instance state. All right. So sorry, I'm typing a little slow here because I don't expect you guys to type all this stuff out. Really, it's just a matter of what we can see in the log messages. So let's go ahead and hit run and see which of what these guys get triggered on our first run, what happens when we rotate, and then I'll show you guys a handy diagram that'll show you everything of what's going on. So we have right here onCreate gets called first. Then our onStart method happens. Then our onResume method happens. At this point, the activity is in the running state. Now what happens when I rotate? I'm going to hit the rotate button on my emulator or on my virtual device. Look at this. OnPause, onSave instance state, onStop, onDestroy, onCreate, onStart, onRestore instance state, onResume. So, a couple interesting things here. First of all, our onPause and onSave instance state, onStop, and onDestroy were all invoked. All of these on your going to way methods all got invoked. So that's the progression that happened. You'll also notice that the second time our activity started again when we rotated it, onCreate and onStart was invoked, as well as on resume, just like before, but now our on restore instant state appears. Put simply, the on saved instant state and the on restore instant state methods are there for you to save and to restore your instant state, which is probably why they're named that way. So before we go into, well, I guess I can go ahead and we can fix the problem already. We have enough information to be able to fix the problem. So let's go ahead and, if you guys are forgetting what problem I'm talking about, it's when we have some sort of instant state and it goes away. You might see some people do something like this. I just want to point this out. Before I show you guys how to actually do this properly, you might see people doing that. If you see somebody doing that, smack them upside the head. That is awful, awful practice. For people who aren't maybe necessarily familiar with what static does here in this context, basically what this is doing is it's turning into a class level variable. It's turning it into a variable that's going to be the same no matter what instance that we have or are using of main activity. So when the first instance of main activity gets destroyed, this variable will stick around. Meaning, to make this code work, all I have to do is at the bottom simply say text view dot set text integer toString counter, right? Now, when I run this code with this program, and wait a year and a half, there you go. Now it'll say 0. If I go up to 10 and rotate, oh wow, look, it's 10. That must mean we fixed the problem. No, it doesn't. This variable is still resident in memory. And it stays resident in memory even when the class main activity is destroyed. The problem with this, well, I guess there's two problems. First of all, there's nobody saying or ever says that you can't have one activity stacked on another activity that's the same class. So you can go ahead and have two main activities running on top of each other if you wanted to. And in that case, they'll both share the same counter. It's probably not what you're looking for, right? Second problem is that when Android decides that your app needs to be terminated for whatever reason, such as running out of memory, and if your app isn't in the foreground, the user probably doesn't care about your app while he's writing an email or surfing the internet or doing something like that, and would rather have your application just be destroyed and stopped, and all the memory of your application be reclaimed, right? When that happens and he comes back to your app, that counter variable will now be back to 0 because it'll have been recreated, destroyed and recreated. So you don't want to do it this way. Android has a built-in mechanism for being able to handle state such as this. So, basically, for every piece of data that you need to persist after your activity has been destroyed and is going to be recreated, you're going to need some sort of identifier, some sort of string identifier. So at the top here, I'm going to say private static final string, and I'm going to go ahead and call this bundle counter, and I'm going to have it be the same thing right there. Okay, what's this for? Why are we creating a constant string value? Well, I'm creating a constant string value so I can have so I can reference the same piece of the bundle that we are going to be reserving for our counter variable twice, once to save it, once to load it, instead of hard-coding the word bundle counter over and over and over again. You know, what's funny is I don't think I've even told you guys what bundles are. Hopefully you guys are starting to get an idea of what they are, but I haven't really sat down and talked about exactly what they do. So here's what they do. A bundle is nothing more than a bag of data that Android holds onto when your activity gets destroyed and might be recreated later. So if an activity gets destroyed and might be created later, Android's like, okay, here's a bundle, stuff all of the things that you need in order to be recreated in this bundle. I'll hold on to this bundle. Then, if the user ever wants to come back to your activity, even if your entire process has been destroyed and reclaimed by the operating system, I'll give you this bundle back so you can reconstruct yourself in a way that makes sense to the user, such as having that counter variable remain consistent. So how do we work with bundles? Now you'll notice that onCreate has a bundle parameter saved to instance state, but we haven't used it yet. In fact, it's going to be null in all instances except when we are recreating an activity. But that's how we get data back out of the bundle. How do we put data in the bundle? Well, it's pretty straightforward. We override a method we already saw. I'm going to say override protected void on save instance state bundle saved instance state. And then I'm going to call super on save instance state save instance state. This method is invoked, not surprisingly, when Android's like, okay, package up all the necessary bits of data that you need to reconstruct yourself and stuff it in this parameter. Then I'll hold on to that bundle for you. So we access this as saved instance state dot, and we'll have our get methods and our set or put methods rather. So it's really just a big dictionary. If you're familiar with .NET, it's a dictionary. If you're familiar with Java, it's like or JavaScript, it's like an object. If you're familiar with Java, it's like a hash map. It basically just allows you to associate a piece of data with a string that acts as a key. So, obviously, since we're on the onSave instance state method and not the onRestore instance state or the onCreate instance state, we want to work with the put methods. So what are we putting? You'll notice there's a put for all of these different kinds of variables. We can put bundles, we can put booleans, boolean arrays, bundles, bytes, byte arrays, chars, blah, blah, blah. Basically all the basic data types plus a couple extras. So what is counter? Counter is an integer. So I'm going to say put int. Now, what am I passing in for the key? Well, we already wrote our key, bundle counter. So I'll say bundle counter. And then what am I passing in for the value? Counter. And that's all we need to do. So with that one line of code, we have now stuffed the bundle counter back into our bundle. All right, fun stuff, right? So now what we're going to do is in our onCreate method, we are going to use our saved instance state. Now you might be wondering, what's the difference between onRestore instance state and onCreate's saved instance state? What's the difference between implementing this method or just using the bundle that's passed into onCreate? Answer to that question is virtually none. In fact, we will 99%, if not 100% of the time, be taking advantage of the saved instance state that is passed into the onCreate method. Okay, so after we set the content view, what I want to do is I'm going to say if saved instance state does not equal null. This null check is very, very important because saved instance state is not going to be passed in on the first time our activity is created. It's only ever going to be supplied as an actual object on a recreation of an activity. So what I'm going to do here is I'm going to say counter equals saved instance state dot get int, which is the opposite of put int, and then I'm going to pass in bundle counter. Now there's an int default value here. I'm not going to worry about it for two reasons. A, it should always find a bundle counter. B, if it doesn't, I'm fine with it returning 0, which in the case of int it will. As you can see, in fact, getInt literally returns getInt key 0. All right, so let's go ahead and hit run. And now you guys know the proper way to handle rotation changes, except of the exception I just got for some reason. Oh, that. Hold on. The virtual device is being a little wonky. Let's go ahead and here we go. Well, let's make sure that it's actually running the right version. I'm gonna hit run again on this. Okay, good. Yeah, I was just acting a little funky. Okay, so now I can hit a button a bunch of times. We get to 10. I can rotate, and we have 10. And I can go up to 15. And we have 15. Notice how, in our logs, we see that the entire activity is being paused, saved state, stopped, destroyed, created, started, restored, and resumed. There's one more thing I want to point out about this before we talk about that diagram I've been talking about for the last 30 minutes. And that is, I'm going to come back into my layout file, and I'm going to go ahead and I'm going to create an edit text. I'm going to say edit text with a width of match parent and a height of wrap content. And I'm going to give it a layout above, or how about below? Well, it'll be below my main text, and I'll give it a margin top of 8 device independent pixels. Okay, so let's go ahead and hit run. Now this is going to be interesting. This is something you're going to have to be very cognizant of when working with views. You'll notice that this edit text has local data to it. I mean, obviously it has local data in it. Otherwise, how does it know what I just typed into it in order to be able to render it? So what do you think happens when I rotate it? You'll notice it all goes away, just like what we did before. Now, does that mean that we have to go in and manually save and restore and edit text, which would be very, very obnoxious for your applications to have to manually go in and save the text out and then re-edit back in? Answer is no, you don't have to. Because if you give your edit text or any view its own unique identifier, an identifier that is unique in the entire view hierarchy, if you give it an ID, it will now save its instance state. So, as long as the edit text has a unique ID, which almost all the time it will, because an edit text without a unique ID is kind of silly, because you want to be able to reference one. But this also applies into any other views that you may have some sort of, any sort of state that might want to be saved. Alright, so that's basically the practical introduction to a sort of down in the trenches sort of introduction to the life cycle. Let's look at that diagram and trace it out. I could have started off this video with this diagram, but I didn't want to. The reason I didn't want to is I wanted to see a practical application of this diagram before we took a look at it in a relatively abstract way. So let's go ahead and talk about it. And this is what we get. Oh, this is such a much nicer diagram than they used to be in the docs. Oh, by the way, I pulled this out of the Android documentation, which is a great resource that people should be aware of. But, so yeah. This goes through all the lifecycle methods that we have been talking about, except for save and load instant state. So you notice it's kind of in a pyramid. We start with onCreate. So we already know what onCreate does. If our activity has been destroyed or never existed, we go to onCreate. Then we go into the created state. Then Android invokes onStart. We get our started visible state, and then it almost immediately will invoke onResume, which gives us our resumed visible state. Started and resumed are basically both synonymous with running. I mean, you'll never run into an activity that isn't in a running state under normal conditions. So, now let's say an application is running, but let's say another activity goes on top of it. Now, I don't mean on top of it in the sense that you switched from activity A or to activity B, or pushed activity A on top of activity B. I mean physically on top of it, where the background of the activity A is still visible. It'll go into the paused state. Your onPause method will be invoked. Now, when your activity becomes fully visible again, your onResume method will become invoked again. However, there's something really interesting, and I really like this about the way they set up this lifecycle here. Let's say you get stopped. Now, under what circumstances do you get stopped? let's say you launch another activity, but that other activity doesn't partially obscure your activity. It is a full screen activity. So you go from activity A to activity B. What happens then? Well, then you go into the stopped state. But what's interesting about that, notice how on pause and on stop will be invoked. So that's really important. It acts like a pyramid, which is why this is shaped like a pyramid. A lot easier to understand than it used to be. I wasn't a big fan of the old diagram. So it's important that when your activity gets stopped by, or let's say your activity gets stopped by the user switching to another app altogether, or answering a phone call or whatever, then your activity can get stopped. Now, when your activity is stopped, it's still resident in memory, meaning all of your views, all of your local fields, all of everything is still resident in memory and does not need to be recreated at all. It's just stopped. Stopped is just a hardcore version of paused, really. Now, when an activity gets resumed, not surprisingly, the onRestart method is invoked. But then, look at that. The onStart method is invoked, then the onResume method is invoked, and then we become resumed. So let's look at that. So I have my activity right here. Let's bring up my logs. Where are you? And then I'm going to just hit the home button right here. And look at that. On pause, on save instant state, on stop. So that's what I just showed you guys. I showed you guys what happens when we lose focus out of the activity. But what's important to understand here is that the activity is still resident in memory. Now, if I come back here and I say, open up my app, notice how I get on restarted, on start, on resume. I don't need to redo the on create. Okay, so that's how our activities get paused and restarted. That's how our activities get stopped and restarted. Let's talk about destroy. Well, when does destroy happen? Destroy happens when your system starts to run out of resources, basically. Or it happens when your activity finishes, meaning your activity is no longer required, or the user presses the back button, or something like that. Then your activity gets destroyed. Now, once it's destroyed, it'll no longer be resident in memory. So we go from resumed, or running. Think about this top thing as just running. Resumed is, I don't really like that name at all. So let's say that the user presses the back button. It'll go from resumed to paused to stopped to destroyed. I should be able to show that. I should be able to hit back. There we go. On pause, on stop, on destroy. Now, because I hit the back button, now if I launch this, notice how we get on create, on start, and on resume. But notice how my saved instant state isn't there anymore. See, if I hit 10 and then I hit back, I get non destroy, and then I go back into it. I get a non create again, but notice how my saved instant state isn't populated. That's because this on destroy is, when I hit the back button, is a user, or the intent of that is for the activity to be finished and done with and no longer be used at all. However, sometimes on destroy will result in such as when you run out of memory, for example. Then it's a different story. Then your saved instant state will be used again. We can simulate this in a couple of ways. You can simulate this by killing the application process, or we can go into our settings. So I'm going to go into my settings, or I guess I can just drag down, can't I? Drag down, settings, and we can come down here to developer tools, wherever those ran off to. Oh, why am I so bad at this all of a sudden? Maybe I... Wow, I didn't even have developer tools enabled. Okay, let's go into developer options. And then in here, what I'm going to do is I'm going to scroll down to don't keep activities. So what this checkbox does is it simulates the device being so out of memory that the device can only keep one activity resident in memory at a time. So now, let's go ahead and jump into my activities example. And let's look at the logs. So let's go ahead and hit a button a couple times. Go up to 10. Now I'm going to hit the home button. Watch what happens. On pause, on saved instance state, on stop, on destroy. Now when I relaunch that activity from the recent activities menu, we get on create, on start, on restore instance state, on resume, and we get our 10 back. But if I hit the back button, we get on pause, on stop, on destroy. We never get our on save instance state because we intentionally destroyed that activity. Anyway, I hope I'm beating this into everyone's head effectively enough because this is really important to understand. Activities are like little islands of functionality, and they need to be able to be restored in a way that, well, prevents users from being confused as to why suddenly all their data's gone. Two more things I want to talk about in this video. First thing, this cycle right here, on resume, on pause, should be where you keep, or where you handle acquiring certain types of resources. Acquiring and releasing certain types of resources, such as the camera. Because most of the time, in fact 99% of the time, on pause is going to be it's going to result in the entire activity being either destroyed or stopped. Now on resume, since it's invoked both when the activity is created and when it's resumed again, and when it's resumed from being stopped, that means it's safe to allocate all of your managed or all of your resources, all of your things that you have to acquire and release, such as the camera service. It's safe to acquire that in your on resume, release it on your on pause, and then everything will magically work. All of the use cases will magically be handled because the on resume is invoked when the activity is created. It's also invoked when it becomes unpaused. It's also invoked when it becomes unstopped. That being said, on pause is a blocking call. Well, in fact, all of these calls are blocking because they all run on the UI thread. The on pause method, if it takes too long to run, could potentially cause some lagginess in the UI and prevent the other activity from launching in a smooth way. So you shouldn't do many computationally expensive things on pause. Instead, you should do those computationally expensive things on stop. Anyway, so that's that. Okay, so basically we just did a whole lot of work in order to handle rotating our device and saving data. If you go online, some people are going to tell you to do this. They're going to tell you, okay, well that's really easy. If your data is getting lost when you rotate the device, just go into Manifest, Android Manifest, and find your activity, which is right here. This is our main activity. And add this magical line of XML code in the form of an attribute, saying Android config changes orientation screen size. Okay, now I'm going to run this. I'll tell you what this all means in a second, but I want to show you what effectively happens here. Watch what happens when I rotate. Specifically, watch the logs as I rotate. Nothing. No lifecycle events are invoked whatsoever. You don't see the on create, on stop, on pause, on anything. In fact, I wouldn't even need to come in here and do my on save instance state. I could just have left the code exactly how it was and came in here and magically said config changes equals orientation screen size. Problem with this is a massive anti-pattern. Highly discouraged. There are very few cases where I find this acceptable. And the reason is Android gives you all the tools to handle configuration changes, to handle screen rotation. And when you do things properly, it'll not only make your activity stable in this case of a orientation change, it'll also continue to make your app stable in cases of running out of memory, of your user switching to another activity, and your activity getting destroyed for whatever reason. By handling the lifecycle events properly, you protect your app against so many uncertain things in a very easy and straightforward manner that there's no reason not to do it properly. This makes it so you don't have to worry about it being properly. If all you're cared about is, oh, you rotate the device and my instance data goes away, I want to fix that. That's all you care about? Sure, go ahead, do this. If you want to make your app resilient to running out of memory, having other applications pushed on top of it, all that fun stuff, then do it this way. It's not much more code. It makes your app infinitely more stable and robust. So this is just a hack, and it's okay in certain circumstances, like maybe for a camera app where you have a camera view or something, and you want to rotate it and not have it release the camera and reacquire the camera every time you rotate the device. Okay, sure, I'll give you that. But for everything else, I do not recommend it. Another thing that this prevents us from being able to do is it prevents us from being able to load in other resources depending on the orientation of the device. Now remember the last video where I showed you guys how you could have a different layout if you're in landscape or in portrait mode? Well, if you have it like this, where you're not telling it to recreate the activity when the orientation changes, then you won't be able to load in a different layout depending on the orientation of your device. You technically can through a method called the onConfigurationChanged, which is another callback, but I'm not too interested in dealing with that. Right now, this isn't something that you'll see it everywhere. A lot of people do it, and for them, it might not cause a bunch of problems all the time, but it will make your app less robust. Just do it right, unless you have a very, very good reason to set that. By the way, just to get some terminology straight, the reason why this is called config changes, which I think is an awful name for this attribute, what it means is technically any configuration change makes your app restart. So if you suddenly attached a physical keyboard to your device, or you got a bigger screen magically on your device without restarting, or you changed a locale or whatever, that results in a config change, a configuration change. Now, configuration changes will result in your activity being restarted unless that configuration change is listed here. This is saying, do not restart my activity if the config change that was going to restart my activity was an orientation change or a screen size change. The reason we have to do the screen size is because the screen size will change when we flip the orientation, because obviously the X and Y axes are getting inverted. Anyway, we might use this for our camera thing, but again, we have a good reason for that. Everything else, do it right, use your bundles. All right, so we're going to have to turn this into a two-parter, so we'll talk about dealing with other activities in the next video. We'll see you guys then.